Hello everyone, welcome to RN tutorials on engineering mechanics. So in this video we are going to discuss about the equilibrium of a body lying on a rough inclined plane when subject to a horizontal force. So here we need to assume a body which is lying on a rough inclined plane. So as shown in figure, I am going to represent the figure. So this is an inclined plane on which we are going to place one object. So here first I have represented the inclination as alpha for the inclined plane. So next I would like to place the body. For this is the body, assume it is under motion, so in downward direction. So whenever it is moving downward direction, the frictional force acts opposite to the direction of motion. So whenever it is moving, I want to apply certain horizontal force which can stop the body, only just stops the body. So that means here we will be applying a minimum force which can make the body to be under static condition, means under equilibrium condition. Okay na. So whenever we are applying the minimum force on the body to stop the body, means the frictional force will be acting opposite to the direction of the motion only. So that means in which direction we will be applying, in the same direction the friction acts. So similarly, so the weight of the body is acting downward direction, assume as a W, and at the same time the normal reaction acts perpendicular to the inclined surface, assume it as R. And next the force which we are applying, the horizontal force we are applying, which is the minimum horizontal force which can just stop the body. If we reduce the force of the quantity minimum force, automatically the motion of the body starts. So that means here we are applying the minimum force to stop the body, to just to stop the body. So in that condition the friction acts opposite to the motion of the body, means in the direction of the force only it will act. So like this the friction will be acting along the inclined plane. So here I have given the P as a name for the minimum force we are applying to stop the body, that means to make the body in equilibrium condition. And the friction is F, which is acting along the plane in opposite to the direction of the motion in which it tends to move. Okay. And the next so by considering these forces we can derive the force, that is the minimum force P required to make the body in equilibrium condition, which is the minimum force. Okay. So when you consider the P, here first I would like to represent the alpha. So this is the angle between W and the R is also alpha. Why it is alpha means from the theorem of perpendicular lines here we can consider. So how can we, means here the W is perpendicular to the this base of the inclined plane, and R is W is perpendicular to this base and the R is perpendicular to this inclined plane. Okay na. So these the angle between the base and the inclined plane is alpha. Similarly these two lines inclined also will be at an angle of alpha only. Okay, that is according to the perpendicular lines theorem. And similarly we can give an angle alpha to this P also. Okay, how we give this alpha to the P with the line parallel to the inclined plane, means here by considering the parallel lines we can give this angle alpha. So how it means, here W and R are perpendicular to this plane, inclined plane and the base, and similarly this P is parallel to the base and this horizontal line is parallel to the inclined plane. So from the theorem of parallel lines also we can take the angle as an alpha only. Okay na. So here these line automatically I've represented as an arrow marks, means this P can be resolved into two components. Okay, so one is parallel to the inclined plane and another one is perpendicular to the inclined plane. Okay, so based upon this resolution we can make it as P cos alpha and P sin alpha. So separately I would like to represent them. So this is related to the component parallel to the inclined plane, means which is P cos alpha. So try to represent P cos alpha, and this line is line perpendicular, that is the component of the force P perpendicular to the inclined plane. So that we can write it as P sin alpha. Okay, these are the two components of the P along the plane and perpendicular to the inclined plane. Okay, and similarly the W, next we go for W. So this W can also be resolved into two components. One is again parallel to the inclined plane and another one is perpendicular to the inclined plane. Here the inclination already we know alpha. So based upon this alpha, adjacent side, adjacent component, we can make it as W cos alpha, and this side we can make it as W sin alpha. Okay, so separately I would like to represent. So this component is W cos alpha and this component is W sin alpha. It means W sin alpha is parallel to the inclined plane and W cos alpha is perpendicular to the inclined plane. So, okay, these are the two components we can resolve for W, which is the load of the body. Okay, and the force, frictional force, is already acting parallel to it, so there is no other component for the frictional force. So by considering all these forces, we can derive an equation for minimum force which is required to make the body under equilibrium condition. Okay, so now try to consider from the forces parallel to the plane. So initially I would like to consider the forces which are acting parallel to the plane here. So parallel to the plane means first one P cos alpha. Here the P cos alpha is the component of the P which is parallel to the inclined plane only. So consider that P cos alpha. Next plus another component we should consider F, which is the frictional force. So the frictional force is already acting along the plane, and this P cos alpha and F both are in the same direction, so that's why we should take the sum of the two forces. Next, that should be equal to, next component is W sin alpha, which is related to the load. Okay, so in parallel forces, it means in forces which are parallel to the inclined plane, P cos alpha is 1, F is 1, and W sin alpha is 1, and here the W sin alpha is acting opposite to these two forces. So automatically equilibrium condition means we can make the sum of the forces is equal to 0, or positive components can be equal to negative components. So that means we can write it as P cos alpha plus F is equal to W sin alpha, because of opposite it is acting. Okay, so from this equation try to write F is equal to W sin alpha minus P cos alpha. So remember this equation. Next we go for forces which are acting perpendicular to the plane. So now we need to consider from the forces perpendicular to the plane. The first case is parallel to the plane and second case is perpendicular to the plane. So perpendicular to the plane is P sin alpha is there. Okay, perpendicular to the plane. Next W cos alpha is there, perpendicular to the plane, and R is there, which is opposite to the W cos alpha. R is also a reaction force which is acting perpendicular to the plane. Okay, so according to their direction we can write the equation as first element R. Okay, R minus W cos alpha we can write, because R is acting upward and W cos alpha is acting downward direction. See here and see here both. Okay, then R minus W cos alpha is equal to, we can write it as, or we can write it as P sin alpha. Okay na, so otherwise we can write it as R minus W cos alpha minus P sin alpha is equal to 0. Okay, so then we can write it as R minus W cos alpha is equal to P sin alpha. So finally I would like to write R is equal to P sin alpha plus W cos alpha. Again remember this equation. Okay, so these two equations are important. In the next slide I will show you directly these formulas. Okay, F is equal to W sin alpha minus P cos alpha, R is equal to P sin alpha plus W cos alpha. These are the two equations we got by considering the parallel forces and perpendicular forces. Okay, next we go for frictional force formula. We know that F frictional force is equal to mu R, coefficient of friction into reaction force, normal force. Okay, R is the normal force here. So F already we got the formula as W sin alpha minus P cos alpha is equal to mu into whatever the R formula we got, write down the R in brackets, P sin alpha plus W cos alpha. So now try to take the mu inside of the bracket, mu P sin alpha plus mu W cos alpha. So now try to separate the terms related to the P multiplier and W multiplier. So now try to write W sin alpha minus mu W cos alpha. Okay, we have taken this mu W cos alpha to the left side. Similarly we need to take the minus P cos alpha to the right side. So is equal to, we can write it as mu P sin alpha plus P cos alpha. Okay, so by separating the W and P terms we'll be getting the equation like this. Okay, now we go for next slide with the same equation. Okay, so in this equation try to take common of W. So take the W common, sin alpha minus mu cos alpha is equal to, again in this equation take the P as common, so P of mu sin alpha plus cos alpha. Okay, so now try to write it as P is equal to, we can write it as W into sin alpha minus mu cos alpha divided by mu sin alpha plus cos alpha. Okay, we have taken this multiplier to the left side, and entire equation we are writing right side. P is equal to W of sin alpha minus mu cos alpha divided by mu sin alpha plus cos alpha. Okay, and again mu, so how can we write the mu, which is the coefficient of friction? Mu is equal to, we know that tan phi with a friction angle. Okay, so tan phi again can be written as sin phi minus cos phi. So in place of mu, again we need to substitute sin phi by cos phi. Okay, so in this equation try to substitute mu formula, sin alpha minus sin phi by cos phi into cos alpha divided by sin phi by cos phi into sin alpha plus cos alpha. Okay, now take the LCM of cos phi. Automatically the cos phi in the denominator here, will be getting cancelled. Then we need to multiply with remaining this term, sin alpha term, and here the cos alpha term. Okay, for completing the LCM. Okay na. So now try to write W of sin alpha cos phi minus sin phi cos alpha or cos alpha sin phi divided by, we can write it as sin alpha sin phi plus cos alpha cos phi. Okay, we can write the equation like this. So when you observe this equation, it is in the form of sin A cos B minus cos A sin B, which is sin alpha minus phi. Similarly here also cos A cos B plus sin A sin B, which is in the form of cos A minus B. So try to simplify this equation. So directly we will be getting W of sin alpha minus phi divided by cos of alpha minus phi. So when you consider this equation, it is in the form of sin theta by cos theta. So finally we will be getting tan theta. So W of P is equal to W of tan of alpha minus phi. Okay, which is the required equation, which will give you the minimum force required to stop the motion of the body. Okay, so this is the minimum force which can make the body under equilibrium condition. Remember, P is equal to W tan of alpha minus phi. Very important equation. And next we go for next case, the maximum force at which the body will be in equilibrium condition. That means here, whenever the body is in motion, by applying certain minimum force, we are stopping the body. Less than that force, the motion of the body starts downward direction. And when we keep on increasing the force, at a particular stage comes when you apply the force more than at that condition, at that point, automatically the motion of the body starts in upward direction. So in that case, the force will be, frictional force will be acting opposite, means in the downward direction of the inclined plane. Okay na. So in that condition, here we are considering the maximum force up to which the body remains under stationary condition only. Okay, above that, when you apply, the motion of the body starts, but here we are considering only the equilibrium condition for the maximum force. So only the difference is the friction will be acting downwards the plane. Okay, in previous case upwards the plane the friction is acting, here the friction is acting downwards the plane. So again we can follow the same procedure, resolving the P2 into two components and resolving the W into two components. Then by considering the parallel forces and perpendicular forces, and by applying the frictional force formula, and by following the same procedure, we will be getting the formula as P2 is equal to W of sin alpha plus phi by cos alpha plus phi. So which is equal to, we can write it as P is equal to W tan of alpha plus phi, which is phi, which is the maximum force, here P2 value. So here this is the maximum force up to which the body remains under equilibrium condition. Okay, so try to derive this formula. Same formula you will be getting, except the negative term or positive term, the difference. So I hope you understand deriving the equation for making the body in equilibrium condition by applying the minimum force and the maximum force when the body is under motion. So once again, thanks for watching my video. Thank you all. If you really like my explanation, please like my video and try to share my video with your friends. And once again, thanks for watching my video. Thank you all.